Area and perimeter of similar figures. So jumping back a few units, we learned about similar figures and scale factors, ratios, all of that stuff. So recall that similar figures are figures that have the same shape but may have different sizes. Their corresponding angles are congruent. That means angles are equal, we say congruent, and their corresponding sides are proportional. They are not equal, they're proportional. So think about printing a photo. You could scale it to a 4 by 6, a 5 by 7, an 8 by 10. We did problems like that before. There's a quick review, and in the review, I'll just briefly go through this. Number 1 says determine the scale factor of the figures below. So the scale factor, we generally use the variable n, if you remember that, and you just set up a ratio. So you always do the image over the pre-image, and this would be the image here. Oops. And this is called the pre-image. I'm looking at the direction of the arrow, that's why I'm saying it like that. And in order to set up my ratio, I'm just going to set up a fraction of 8 over 4. So 8 to 4, you have to do the same sides. So the proportional sides would be 8 to 4, which simplifies to a value of 2. That means the scale factor from the smaller figure to the larger factor is 2. You could have also set up a ratio of the side 6 to 3. Again, remember it's image over pre-image. So 6 to 3 would also simplify to a value of 2. Okay, number 2 in the review section says, the plans for a flower garden show that it is 6 inches wide on the plan. If the scale factor for the flower garden is 1 to 12, what is the actual width of the flower garden? If you remember doing problems like this before, these problems require you to write a proportion in fractional form. So if it says that the garden is 6 inches wide on the plan and the scale for the garden is 1 to 12, that means we're going to set up a ratio of 1 over 12, meaning for every 1 inch, it's actually 12 inches. On the plan, it's 6 inches, so what is it actually going to be is going to be our variable x. All right, so 1 inch on the plan represents 12 inches in real life. 6 inches on the plan is going to represent what in real life? That's what I just set up as a ratio. And in order to solve for this, we're going to cross multiply. So we end up with x is equal to 72. And of course, it's 72 inches. So the width of the garden is 72 inches, which if we convert that to feet, that would be 6 feet. Okay, so now that we've done a quick review on what the scale factor is and how we set up proportions and ratios, let's scroll down and look at the perimeter and area of similar figures. So for perimeter, it says the ratio of perimeters is the same as the scale factor. So first I'm just going to start by finding the scale factor. I'm going to find the scale factor from the smaller to the larger image. So we're going to say this is the image and this is the pre-image. So remember the scale factor is determined from the image length on the numerator. I'm going to use 24, which corresponds to 16. 24 over 16 and 24 over 16 both have a factor of 4, and that simplifies to, both have a factor of 8, which simplifies to 3 over 2. So there's the scale factor. Okay, so now set the scale factor aside for a second, and I'm going to find the perimeter of each figure. So the perimeter of the small figure, or the pre-image, we're going to add up our side lengths. We have 2 side lengths at 10, so 2 times 10, plus 2 side lengths at 16. When I add these together, we end up with 52 for our perimeter. And the perimeter of the large figure is going to give you 2 side lengths at 15, plus 2 side lengths at 24. And that is equal to 78. So now if we set up a ratio of the perimeters, what we're going to do is we are going to set up, same thing, we're going to do the large figure or the image on top divided by the pre-image. So we're going to do 78, that's the larger figure, divided by 52. And if we simplify this, we can simplify, let's see, what goes into both of these? 26 goes into both of these. 26 goes into 78 3 times, and it goes into 52 twice. As you can see, the ratio of the perimeters is the same as the scale factor. So I'm just going to make a note, ratio of perimeters ratio of the perimeters is the same as the scale factor. And this is very important. It's going to be helpful in future examples. So sometimes you won't be able to find the scale factor, but you will be able to find the perimeter. And in that case, you can actually work backwards and you can find that, or vice versa. Now let's take a look at the same figures. So same 2 figures here as what we had here, but we're going to look at the ratio of the areas. And if you read my little description, it says if the scale factor of the sides of 2 similar polygons is m over n, then the ratio is the scale factor, or m over n squared. So let's check that out. We know that the scale factor that we already found right here, we know the scale factor is 3 over 2. Now let's find the areas. So if we find the area of the small rectangle, we're going to do 10 times 16, which gives us 160. If we find the area of the large figure, we're going to do 15 times 24, which is equal to 360. So now let's take these 2 values and let's set up a ratio of the areas. So a ratio of the areas would be the numerator of image, which is 360, divided by 160. And we need to find what number goes into both of these. So let's see, we could do 360. Both of these have a factor of, let's see, 40. So 360 divided by 40 leaves you with a value of 9, and 160 divided by 40 leaves you with a value of 4. Okay, so here is our ratio of areas. Now let's take a look. If we take this scale factor right here, and we square this scale factor, we square the numerator and we square the denominator, that's going to give us a numerator of 9 over 4, which, as you can see, is the same thing that we just found with the ratio of areas. So the ratio of areas is the same as the scale factor squared. And that is also going to be important in future examples. So let's make our way down to the first set of examples. And it says, given the similar polygons, write the ratio of their perimeters and the ratio of their areas. Find the ratio smaller to larger of the perimeters and the ratio smaller to larger of the areas. So in this case, if it's saying smaller to larger, The smaller is going to be the pre-image, and the larger will be the image. Now, we don't have enough information to actually find the perimeters. We only have one side length. So recall that the ratio of the perimeters is the same as the scale factor. So if you can find the scale factor, then you can find the ratio of the perimeters. I'm going to abbreviate this. I'm going to write same as SF for scale factor. So I'm going to find the scale factor, and I'm going to set it up as the image of 9 divided by the pre-image of 6, and this is going to simplify to 3 over 2. This is your solution. That is the ratio of the perimeters. For part 2, or part B, now we are asked to find the ratio of the areas. So we're going to look at the same thing here. We're going to identify the smaller figure as the pre-image, the larger figure as the image. We know that the ratio of the areas is the same as the scale factor squared. We found that right here. So same as, abbreviated as SF for scale factor squared. That means we can take the scale factor from part A, which is 3 over 2, the scale factor between the figures. We can square this value, and that's going to give us 9 over 4. 9 over 4 is going to be the ratio of areas. And that is why it is helpful to be able to compare the scale factor versus what the area and perimeter actually are, because sometimes you don't have all of the information and you're going to have to use one or the other. So remember that the ratio of the perimeters is the same as the scale factor, and then the ratio of the areas is the same as the scale factor squared. Okay, moving on to the next example set. Part 2 says find the area of similar polygons. We're looking at triangle JKL, and we know that it's similar to triangle PQR. We also know that we are looking to find the area of the shaded figure. So if we're trying to find the area, we know that the ratio of areas is the scale factor squared. So let's start by finding the scale factor. And it doesn't really matter which one you name as the pre-image or image, pick whichever one you want to use. Let's switch it up here. Let's call this one the image. Let's call this one the pre-image. It doesn't matter because we're finding a missing side, so our overall answer is going to be area. That's what we're looking for. So let's start by finding scale factor, and scale factor is going to be found by the image length. I only have one length on here, which is 12, divided by the pre-image length, which is 15. You do have to confirm and make sure the sides are corresponding sides. So in the statement, notice that JK is corresponding to PQ. So it looks like my statement is good. And the scale factor actually simplifies to 4 over 5. After we find the scale factor, let's find the ratio of areas. And the ratio of area is found by taking our scale factor of 4 over 5 and squaring this value, which is going to give us 16 over 25. 16 over 25 is the ratio of areas. Now we're going to set up a proportion of the ratio of areas to the actual areas. So when I set up the proportion, what I'm going to start with is I'm going to start with the ratio of areas, which is 16 over 25. That's what we found right here. So 16 obviously represents the smaller figure, while 25 represents the larger figure. So I'm going to set this equal to a ratio of the actual areas. So this here is the smaller figure. That's going to have to go in the numerator. The area is 30. We're looking for the area of the larger figure, so I'm going to use the variable x. So again, smaller figure in the numerator on both of these ratios, larger figure in the denominator. When we cross multiply here, we end up with 16x is equal to 750. Use my calculator to divide 750 by 16, and x is approximately 46.875. So I could say the area of triangle PQR is approximately 46.9 square inches. And that would be my final answer. So I use the ratio of the areas in order to calculate the actual area. Let's repeat the process quickly with number 2. So we're going to do the exact same thing. We're going to start by finding the scale factor. The scale factor we're going to represent with a variable n, and I'm going to use the first figure of 8 divided by 5. So 8 over 5 is my scale factor. Next, I'm finding ratio of the areas, which we use the scale factor for. So we take 8 over 5, we square this. This is equal to 64 over 25. And that is the ratio of areas. So I'm going to use the ratio of areas and I'm going to set up my proportion. My first term in my proportion is going to be 64 over 25, which is what I just found. Obviously, 64 is the larger figure, 25 is the smaller figure. We know the larger figure has an area of 32. We're looking for the area of the smaller figure. So larger figure goes on top, smaller figure on the bottom. Cross multiply here, we end up with 800 is equal to 64x. Divide both sides by 64, and we get x is equal to 12.5, and this would be square centimeters for our answer. So the area of the smaller figure is 12.5 square centimeters. Okay, that's it for the notes for today. So please try to complete the on your own section by yourself, and you can come back to the video to check your answers. Let me know if you have any questions.